We will now look at the requirements and practices associated with the 6R MO4 course, entitled Commercial Design, which is different in approach to the 6R MO1 course. The 6R MO4 course in RMT focuses on a synoptic task of a student's own choice and offers individuals the opportunity to demonstrate the skills and competencies assimilated during the entirety of the course so far. In this course, students are required to work on a single integrated design and make a task that reflects how a professional designer might work in dealing with a design problem and its resolution. They have free choice of design task, but must work with an identified client or small user group in a commercial manner, seeking feedback and consultation at a number of stages in the design and make process. It is a requirement that students should consider sustainability during the design process and the impact their product might make on the environment. Work is presented under the headings shown on this slide. The first section of this course concerns research and analysis, where a design brief should be written based on a viable problem related to the needs of a client. Analysis of the problem should include a detailed client interview to determine and clarify design needs. Students are not working for themselves, so must take into consideration information gathered from this meeting and reflect this when writing the product specification. The client should be real and not, as is sometimes the case, made up by the student. Where no true client is identified or used, any client input and feedback will inevitably be subjective and superficial. A client can be anyone offering a design problem to be solved. This slide shows two examples of starting points, where the problem is contextualized and a detailed client interview is carried out to determine design needs. A summary of analysis is written to guide research, so that it is directly relevant to the problem, is selective and succinct. When gathering research, students should focus closely on being highly selective to ensure that the gathered information is useful in informing subsequent stages of design development and is directly relevant to the client's needs. Analysis of existing similar products is an important activity that students should use to find out about materials, processes, and construction methods used in producing similar commercially manufactured products. And it is important that evidence of high-level technical understanding is shown by students. The slide shows some analysis of existing commercial products similar to those being designed. Information on materials, performance, construction, and other aspects of design is gathered, to use as reference when designing. When using product analysis, students should avoid simply quoting manufacturers' information or making superficial observations regarding aesthetics and retail cost. Where mind maps are used as an analysis tool, students must ensure that these are focused closely on the problem in hand and do not use generic terms that could be applied to many other products. The mind map on the left is simplistic, generic, and lacking in detail. The one on the right is more informative, but still lacks focus on the product. Mind maps in general do not elicit much useful analytical information, unless they are detailed and focused on the design needs of the product established during the client interview. Questionnaires are often used to gather information and are distributed widely, but this is poor practice when the student or designer is working for an individual and has carried out a detailed interview to establish design needs already. Questionnaires are only valid when a student is working with a small user group, where a range of opinions may be required. The slide shows typical generic materials research, much of which will not be used in designing. It would be more appropriate to carry out this aspect of information gathering once design decisions have been made regarding material requirements, making research more selective and relevant. Research should be focused and succinct and contain no worthless padding. Copious amounts of generic information downloaded from the internet or cut and pasted from technical sources without accompanying annotation, justification, or selectivity carries no currency value and is a waste of time and effort. At the end of the research section, students should summarize their findings to identify key information that must be included in the product specification as a priority. It is essential that a strong specification is developed, as it will be used to guide design ideas and to check their viability as they progress. Specification points should also be used during review, evaluation of the final design proposal, and testing and evaluation of the final practical outcome. A specification should be organized logically, and this can be achieved by using such subheadings as purpose, user requirements, performance requirements, materials and/or components, size, safety and quality, scale of production and cost. Specification statements should be technical and measurable wherever possible, so students should ensure that there are several points made under user requirements and performance requirements, as these headings are where such points are made. Specification statements should also be justified to explain why they are relevant to the product. Sustainability should be included in the product specification, and this may refer to the environmental impact of extraction, use and disposal of materials. Students should present evidence of using research and of having consulted with the client to ensure that specification points are mutually agreeable and that they meet the needs identified earlier. The slide shows two examples of good product specifications, where there is evidence of technical, measurable and justified statements and reference to research. When designing initial ideas, students are encouraged to use their creativity to produce a range of alternative designs that address the problem in hand and conform to the product specification. Students should present a range of alternative ideas that are realistic, workable, and are annotated with technical information on materials and processes that could be used were designs taken through to manufacture. It is better to produce fewer, perhaps 3 ideas that are very well detailed, rather than several that lack information. When annotation specifies that a subsystem of a design adjusts, rotates, or moves, these features should be explored graphically to show how they might operate. It is not sufficient to simply state that a design detail will occur. At A2 level, students must demonstrate how it will happen. Without detailed graphical exploration, many designs will be no more than body styling exercises. As it progresses, each design idea should be evaluated against specification points to check its viability. Subjective statements should be avoided. Comments must be justified to say why a design meets or fails to meet specification points. Client comments should be sought at this point. Client consultation should always be a feature of designing initial ideas. The slide shows alternative designs for a seating project, where details of design features are explored graphically and explained through succinct annotation. Client feedback is recorded to check design requirements. Students should explore a range of approaches to their work in this section, demonstrating their advanced knowledge and understanding of resistant materials through detailed consideration of technical detail, materials, techniques and processes when producing realistic commercial design proposals that match the points of specification and client needs. Annotated information presented by students should reflect their knowledge and understanding gained from Units 1 and 3 of this course. The review section is not well understood. Its point is to encourage students to review their completed alternative design ideas against specification points and each other, to determine which is the best fit and should be taken forward for development. Review should be presented formally, rather than consist of comments tagged onto design ideas. Comments should be objective and relate directly to specification points, especially those that are measurable and performance-related. Review statements should include reference to sustainability, and detailed client feedback should be sought. The results of this section should be summarized to explain which design and features from other initial ideas are to be taken forward for further design input and development. In the development section, students are required to develop a final successful design proposal based on the results of review and in consultation with the client. Development means change, and this should be illustrated by students through their ability to bring together the best or most appropriate features of their design ideas into a coherent and refined final design proposal that meets all of the requirements of the product specification. There must be evidence of the developed design having moved on from an original idea through the results of evaluation and testing and client feedback. It is not acceptable to simply take an initial idea and make superficial or cosmetic changes to it, and then present it as a final developed proposal. Students should include as much detailed information on all aspects of their developed design as possible, as this is an opportunity to show knowledge and understanding of their design and make activities, and to illustrate the gains made through advanced studies of resistant materials. Modelling is an important aspect of design development, and should be used to test features such as proportions, scale, mechanical details, subsystems, etc. Modelling can be done through the use of traditional materials or through the use of 3D computer simulations and/or rapid representation techniques. Evidence of real-world modelling should be presented through clear, well-annotated photographs. Whatever method of modelling is adopted, students must make clear what aspects of their design are being tested and what they have learnt from modelling. The result of development should be a clear and detailed final design proposal that includes technical details of materials, processes, techniques, and fixtures and fittings that will be used during product manufacture. There should be enough information present to enable a skilled third party to manufacture the product. The final developed design proposal should be evaluated objectively against the points of specification to justify the design decisions taken, and recorded in detail by students. Client feedback should be recorded in detail at this point, in order to justify and clarify final design details that may be compromises between the student's ideas and the client's preferences. Marks are awarded for the quality of communication in design, review, and develop, and students should present their work in this section using communication skills of high quality. Most students are skilled users of ICT, and it is at this point that the use of 2D and 3D CAD would be appropriate in displaying design details and features using the power of ICT. Communication skills are important in conveying ideas and should reflect the gains made 1 year on from AS studies. Students are encouraged to use any appropriate means of illustrating their work that they are comfortable with, as long as the results are clear and easily understood. Effective annotation is an important feature of this section in enabling students to explain details of design thinking and to offer evaluative statements regarding their design proposals and the needs of the client. In planning, students are asked to produce a detailed production plan that explains the sequence of operations that their product will go through during manufacture. A work order or schedule should be produced, and this could be done in the form of a flowchart or table, and should include the order of assembly of parts or components, tools, equipment, and processes to be used during manufacture. Planning statements such as drill 4 holes or bend bracket to the correct angle would be of no help to anyone trying to follow the plan. Statements must contain quantitative information, such as how many holes of what diameter must be drilled, and what angle must the bracket be bent to. Planning implies the consideration of time, and it is essential that references are made to timings and deadlines during manufacture. If a Gantt or time chart is used as part of this section, it is important that students only chart activities relating to the manufacture of their product, and not the whole of their design activities. Time should be recorded in hours or minutes, not in lessons, weeks, days, or dates, as these units give no indication of real time. Quality control points should be identified, and quality checks should be described to say what the checks would be, how they would be carried out, and what equipment would be used. Questions such as, "Is it the correct size?" or "Is the corner a right angle?" are questions, not checks, and cannot be credited. Similarly, safety checks should be considered as part of planning for manufacture, and these must relate directly to the manufacturing activities of the intended product. Students should realize that planning is a forward-looking activity, and this should be reflected in their use of language. The term, "the next step in the sequence will be," implies an activity that will occur in the future, which is appropriate. However, to say, "the next step in the sequence was," is a statement implying an activity that has already taken place, which is retrospective, not part of a plan, and cannot be credited as such. In the making assessment criteria, students are asked to produce a high-quality product that meets the requirements of the specification and fully matches the final design proposal in terms of function, sizes, finish, etc. The quality and complexity of manufacture should reflect the gains made in skill levels 1 year on from AS work. During manufacture, Students should demonstrate their understanding of a range of materials by selecting, using, and justifying those that are appropriate to their needs in terms of properties and working characteristics that were detailed in the specification and work plan. Students must show demanding and high-level making skills in order to achieve the high category of marks in the making section. So it is essential that the product under construction offers enough complexity to allow access to high marks. The level of complexity will already have been established at the design development stage. So it is important that students who have high potential are guided towards appropriate levels of response at an early stage in their work to ensure their success. Marks in the section headed Use of Tools and Equipment are gained for demonstrating skills and competencies in manipulating tools and equipment when manufacturing component parts of a product. For high marks, practical work should show high levels of skill resulting in precision and attention to detail. The slide shows a very comprehensive set of photographs, or diary of making, which illustrate clearly a wide range of skills and processes that demonstrate precision and attention to detail. Importantly, each image is annotated to describe what is happening. It is not necessary to take as many photographs as shown on the slide, but those submitted should show the skills and processes that justify the marks awarded. Where a student uses limited or repetitive skills that are simplistic, higher marks cannot be achieved, no matter how well the skills are used or how well the product turns out. The product and skills used must be appropriate to A2 levels of response. While Edexcel encourage the use of new manufacturing technologies, where CAM is used, this should not exceed 50% of manufacture. Over-reliance on CAM does not allow students to fully demonstrate a range of personal manufacturing skills. In order to score high marks in the section headed Quality, students must produce a product that is well assembled from component parts, fully functional, matches the final design proposal, and is appropriate to A2 levels of expectation. If a product is assembled from component parts that were made using only moderate levels of skill, but were well assembled into a product that was fully functioning, matched the final design proposal, and was appropriate to A2 expectations, then high marks can still be achieved. Where a student fails to reach higher levels of credit in use of tools and equipment, this does not mean that they cannot achieve higher marks in this section of making. For high marks in this section, students must justify the selection of materials used to say what qualities or properties make them suitable for use. As evidence of the quality of manufacture, clear photographs must be submitted that show enough detail to support the credit awarded during centre assessment. As photographic evidence is the only proof of manufacturing quality, it is essential that images convey details of levels of difficulty and complexity of construction, so it is unlikely that a single image will achieve this. A series of photographs taken over a period of time during manufacture is the ideal way of highlighting processes used and providing examples of precision and attention to detail that may not be readily noticeable in an image of the finished product. Marks for complexity and/or level of demand are awarded for the challenge presented to students in making their product. High marks are achieved for evidence showing a range of demanding skills and processes. Extended help from teachers or technicians and overuse of CAM will reduce the level of challenge to a student and will inevitably reduce achievable marks. Where processes have been outsourced because of limitations of school facilities, this must be taken into consideration when marks are awarded. Where a student goes off-site to do specialist work, this is acceptable, as long as there is photographic evidence to support any work done by the student and a teacher witness statement as proof that the work was genuinely that of the student. When the product is completed, students must test and evaluate the outcome to check its fitness for purpose. The finished product should be tested under realistic conditions to determine its success. Measurable performance-related points of specification should be used during testing. And tests should be described to say what is being tested, how tests were carried out, and what the results of testing were. Where only limited performance-related criteria were included in the product specification, testing will inevitably be limited and simplistic. Testing must be objective and should include detailed feedback from the client, who should comment on the same specification points as the student to ensure objectivity. Photographic evidence of testing should be submitted to support tests carried out. Evaluative comments should be made by both student and client to justify how specification points have or have not been met. Marks out of 10, or ticks and crosses, should not be used to judge the success of a product when set against specification points. There should be discussion to justify comments. Information from testing, evaluation, and client feedback should be used by students when making suggestions for modifications and future improvements to the product. Suggestions for modifications should focus on improving the performance of the product or its quality, and should avoid superficial cosmetic changes that are wholly subjective. Life cycle assessment should focus on a student's product and should avoid generic information that could apply to any product. Effective testing and evaluation can only be carried out if a product is complete, so it is essential that students refer and adhere to their work plan to achieve the planned time for this activity.